You invented infinite code context.
Yes.
What does that mean?
If you've been coding with LLMs for a while, you know that context is everything, right? You start building something, it grows beyond 20,000 lines. You're maybe now up to 100,000 lines. If you're in a big enterprise, you started with 1 million lines.
Yeah.
So if your copilot or your favorite coding tool cannot have context of the whole code base, which is the case where it has like probably Claude with 200K tokens or Gemini with a million or 2 million, right? But even then, the best you can fit into it is 20,000 lines or maybe about 100,000 lines, right? But that's just not enough, because what the agents then do is they summarize the rest of the stuff and then they make mistakes, which is what we learn from our customers. We solve that problem, right? You can connect a repo with 20 million lines, 100 million lines to Blitzy. We will onboard it, graph it, understand it, and we will have context across the entire code base when you want to make a change, a refactor, or add a feature.
So what does this mean for the customer?
For the customer, you're no longer limited by how much code you can onboard or how much code you can feed to an AI tool, right? And expect it to intelligently produce large-scale changes with the context of the entire repo.
So walk us through maybe a 20 million line repo example of a customer using Blitzy today. What value are they going to get?
Right. So with that particular customer, they tried many times to document the entire repo. They spent 6 months on it, but could not do it. They tried to modernize their front end, and they wanted to make it, React based, more compliant, more easy to use, but they failed at that. And they had a laundry list of things that they wanted to do, but they just could not get to it because no one understood the entire repo. Even they were surprised with some of the things that Blitzy found in that repo, which is totally reasonable given that you have 20 million lines. It's really hard for anyone to comprehend that, right?
I couldn't have 20 million lines of words in my head, you know what I mean? Like, let alone relational context.
Exactly. Like we documented VS Code,
Yeah.
which is the #1 IDE used by everyone on the planet. Some might call it just a source code editor. To them, say yes. That was 2 million lines of code, right? And this was 20 million lines.
Yeah.
So we solved that problem for them in a week, right? It took 48 hours to onboard all their code.
Of inference.
Of inference time. That's
Yeah.
just inference time. And it took another day to produce the document, get it to them. And they worked with us to improve the context that agents were seeing, because quite often what happens is that there's things in the repo, but that's an incomplete picture, right? Only the developer knows that the React modernization that's in the code actually failed, right? The agents don't have context, the humans don't have context. So by simply looking at the code, you cannot paint the entire picture. But Blitzy's platform lets you add that context and provide that to all of the agents working on your document, or on your repo, right? Which is like millions of lines of code, thousands of agents, and every one of them knows the context that they need to document that repo. And they got it to a reasonable level of accuracy.
Yeah. And so now, for the first time, the code, which has been the source of truth, plus some ideas in the developers' minds on sort of how they're applying that, can be wrapped into an accurate technical design document.
Yes.
In a matter of days.
Yes. And now they have that document as the baseline, right? It does not even come close to including everything, right?
Of course.
It has like 300 pages. It does have a 1,000 feet summary of everything that's in there, which is what is a great starting point even for them, right? Because they didn't even have that. Like they really struggled on that part. So you now have that as a starting point. Blitzy now allows you to go deeper into every single module and get you another document for every folder in the repository, right? So by the end of this process where Blitzy gives them a document, they review it, fix any gaps, and they now have the entire repo documented, right? For 20 million lines, every module documented. When they want to make a change in the future, hey, we have this particular module, we want to add a new feature just to this, right? And it may need context of just that module, or it may need context of the entire repo. They now have the flexibility to decide what they want to do and get precisely that done with the document being up to date.
Yeah. And documentation for us is maybe 1% of the value we aim to provide. I'm sure there's probably a litany of documentation startups that this invention just wiped out. But the reason we had to solve this problem is because we do batch scale autonomous development, which means we are writing hundreds of thousands or millions of lines of code as is required.
Yes.
And so talk me through the process of coming up against the limits of, I think we were at 1 million lines of code context relationally before this, coming up to that limit and then solving towards infinite.
Yep. Well, I think the key driving factor from us going to, let's say, 1 million lines of code to infinite, right, is the ability of the models to be able to do more with the context,
Yep.
right? So Claude 3.7 is significantly better than 3.5 at working with a larger context. Even though it has 200K tokens, it is able to do more with that context, right? Gemini, with its 1 million context window, is even better, right? O3 Mini is, again, one of our favorites. Really good at structured outputs, really good at specific use cases. And we also use the Meta Llama stack. The point is, there are now a lot of competitive models out there. Claude is no longer the only great coding model, and OpenAI is no longer the only great image model or the only great creative model, right? Because of that, we're able to build this system that really marries the strengths of the best models in the world, right? And is able to produce this experience by leveraging all of their strengths, where effectively you're able to achieve infinite code context, right?
Yeah.
It's not an infinite context window.
Yeah, of course not.
We're not loading everything up simultaneously into your code, into your memory, right, to get you to do things. But the point is that you don't have to do that,
Yeah.
right? Even at runtime, when you're processing a use case,
Yeah.
it is modularized,
Yep.
it is containerized,
Yep.
right? And you can focus on the principle of relevance. So if a
Yep.
developer is making a change, they're going to work on a specific set of files at a time,
Yep.
right? That's how developers can even work with
Yeah.
20 million line repos, right? We mimicked the same process and we automated it exponentially at that scale, right? Where we can deal with, we're no longer limited by the size and scale of the code base, and we are able to contextualize the specific files, components, and modules that are relevant to the task at hand, and we're able to recruit dynamically any number of agents that we need to fulfill that task,
Yeah.
and then get them to coordinate and work with each other and deliver that result to the customer with some degree of validation.
Yeah, I think every word in infinite code context is chosen very carefully because what it is not. To your point, it's not a window. We're not this is not a single LLM referencing memory. That would be not even how a human would work, right? But it's also specific to code, right? Code is relational, and by ingesting code, we've created a system that ensures that we dynamically insert the perfect context for that line of code just in time to know everything that anyone would need to know relevant to everything else in the repository.
Right.
And so sometimes I like to share how you would break Blitzy's infinite code context, because that kind of brings home how robust it is. So it is possible, if you put 100,000 lines of code into a single file,
Right.
that Blitzy then could not ingest that.
Yes.
Nor could your IDE, by the way. It would also slow down or break.
Right.
And so insofar as the code is structured in a way that an IDE could handle it, then Blitzy could ingest it at any size. And so I think that really kind of brings home for folks the design of the system.
Right. There are a number of other ways to break it.
Yeah.
Like, for example, if you had a really flat structure,
Yeah.
and you had everything in the root folder,
Yeah.
which is not how developers typically work.
Yeah.
But if you had something like that, then that could potentially break it.
Yeah.
As you described, if you have an insane amount of lines, 100,000 is a good number.
In a single file.
In a single file,
Yeah.
right? Then that would
Yeah.
break it. But that brings a couple of other points to mind. For example, we have this scenario where we try to process the file using one model that has 200K tokens in its context window. If that fails, we try to bring in a bigger model, right? And we do this iteratively until we reach maybe Gemini Pro with 2 million lines, 2 million context tokens, right? And if it fails with that, then that's the only case where we cannot work with that use case. And that is super rare because that's a very large context window. But then that becomes the question, Gemini already has a 1 million context window, right? So should we expect that as models' context windows get bigger, will they automatically be able to solve this problem? And the answer, at least in my opinion, is a resounding no. And that's quite a lot of times counterintuitive to a lot of people. But it's important to understand that even if you took Claude today and loaded a large file or a large enough code base into its context, right? Into, let's say, about 100,000 tokens, the quality or the capacity of Claude, even with reasoning, to be able to retain all of the details at the line level in your input is low, right? There's a leaderboard for this, and for Claude in particular, beyond 100K, it drops down to 32% on that leaderboard. Gemini is a lot better, but even for Gemini, I ran a few tests, and I wasn't too impressed with Gemini's code generation capabilities. But it is definitely a massive improvement from before. But the point really is, with the transformer architecture, the way these sequence-to-sequence models work, the way this whole ecosystem is designed, even though they're great at code generation, they're not the best at precision and at retaining specific details at a line level. That is precisely what we've solved with our solution. So it's not just about how much information we can comprehend. It's also about focusing on the details. So that is why Blitzy can pull out things that you didn't even know exist in the repo, because it can reference and search across every single line in your code base, and it also cites what files it referenced, right, to come up with that answer.
It's not about just fitting everything in memory. It's about only putting what is absolutely relevant in memory, right? And having the perfect context. Because if you put everything that is relevant and a bunch of noise around it within a context window, you will get poor results, right? And so when we say precision, really it's about what is relevant in every single line that you write. And there's a whole additional art around writing millions of lines of code, right? And so what is relevant when you write line number 1 versus line number 900,000 changes, right? And so talk to me about dealing with that complexity of batch building in relation to having that underlying base set of infinite code context.
Right. So that is a unique challenge, as you described it, in its own, right? And the struggle really, if you look at the Reddits for anyone using Cursor, Copilot, or all of those tools, is that they expect, they write a lot of prompts to the agent, and they create like a PRD file or a spec file that explains the code base. So the users are really trying hard to give it the context that the model should have. But this model now is dealing with all of that context and all of their code base. And then Cursor doesn't even give you the entire context window unless you're using the max mode that they just released, right? So Cursor is already cutting down that context window. There are other tools that do not do that, but the problem does not change, right? The fundamental problem is the agents are overloaded with context, and as a user, you have no control over that. All you're doing is working with your code, and giving it some prompt, right? Hoping that it does what you think, but it's frustrating when it does not. We've solved for that exact problem, right? Let's put that into more context. An agent working on the database for a project that has database as one of the components, right? That agent does not necessarily need to know about the UI. All it needs to know is the schema that the UI uses, if this is linked to the UI or the backend. Right? As long as it knows the schema and as long as it knows the requirements and the kinds of data that it has to deal with, that agent is good, right? If you overload it with the UI, and you can have hundreds, if not thousands of UI screens and widgets and components, it is going to be distracted, right? And the same applies whether you're working with APIs, whether you're working with CI/CD, any part of the entire system. So if what we've done to achieve this is to slice and dice your code and make it specifically relevant to that particular agent, so that one agent only works on that piece of code, right? And even before that, as a starting point, ground all your designs in a single technical specification document. So that document that we were chatting about as the first step, you generate that, you review that. If that is good, when you modify that document and maybe request to add a feature or refactor and hit build, we're going to pick up specific sections and hand them off to that agent. And that agent also has the ability to look up other sections if they need to, right? So sometimes you need more context. That agent can go and look up additional sections, additional files, search the entire code base. So we really enable the agents to do their thing. And from our side, we just make sure that we're limiting how much information we're dealing with. And ultimately, the models themselves are really good, is what we've seen. And they're great at solving these tasks for us.
It's sort of like if you had an engineer working on the DB, like where does their area of work rub up against the next person, right? And like what do they not care about at all? And if you know about that for sort of every piece of technology, or at least you're able to codify that for every piece of technology and every part of the stack, then you're able to set the system up for success.
Right. And you bring up a very important point about collaboration, right? Human collaboration is what sets everything going, right? It is impossible for a single developer, for example, to work on a certain size of code base. There's a threshold, right, where that becomes really hard and challenging. So that's why you bring in multiple developers, you have them review each other's work, and multiple developers have multiple areas of expertise, which is also true with our agents. They are specifically purpose-built for the tasks that they work on. But there comes the point where the database agent that we talked about earlier has maybe finished their job or is working on it, and the back-end agent needs to understand what that piece of work is. And or someone needs to review it, which is also an agent, right? So we've enabled that communication channel between the agents in real time, right? So if an agent has built that file or is working on it and another agent needs to reference it, they can do that. They can communicate, get the requirements back, get the current state of the work of the file back, and then use that as their reference point. Which is why you don't have like patches of work across the entire repo. Everything communicates and fits well into one cohesive piece of work that the agents are collectively producing.
And when you look at our logs, our Langsmith logs, big fans by the way, you'll see essentially agents will be blocked, and they'll be like waiting for this part to get finished, just like a human will get blocked, and they'll query and check, and they'll query and check, and then they'll have it, right? And so this goes all the way throughout the stack. And so it's not just like, we say it's like at the speed of compute because it's super catchy. It is at the speed of compute, but there's these actual bottlenecks that are happening just in compressed into minutes, or over a long enough code base, hours, of course, that are the exact kind of bottlenecks that would occur over the course of weeks, months, or years on these projects.
Yes, and this is by design. We wanted this to mimic the human development process. Everything about Blitzy is built around the human process. You're not writing prompts all day. You're working with documents. The agents are using a process that is tried and tested for many, many years, that humans have built software. And we really want this to be an asset to the engineering team. We want the engineering team to be embedded into this and have senior developers review the specs and have other developers work on what's left after producing the code.
So from a meta perspective, not the company, the concept, we first create long-term memory of every relationship and connection within that code base. Create full understanding of it, right? That long-term memory is usable, searchable, and shareable from every agent within the system. There are a stable of agents with many, many different skills in the stack, and a plan for those agents provided by the humans, which is translated in a tech spec. As we submit the tech spec for inference, the agents, starting with an architect, typically will plan the build, dynamically call which agents are useful for that scenario. They'll reference spec in long-term memory and start to build. And they will dynamically coordinate in conjunction with the plan in the same way that a human might be gated at each step. And then throughout this process of build, there's a continual process of validation, right? Because we get the advantage of not having to show something right away in the UI because we're an inference time compute heavy product.
Right.
So we can validate and validate and validate and validate with different LLMs at each step to say what comes out on the other end is the absolute limit
Yes.
of what you can get with generative AI.
Yes.
And then before we give it, we can say, let us check everything that we couldn't quite do yet. And let us build a list for our counterparts, the human engineering team, to take it to 100%.
Right. And I think that list is essentially, typically what we see is that sometimes there are some dependencies that we just don't have access to.
Yeah, in the long-term memory that we never
Right.
were provided by the humans, the agents,
Right.
Yeah, yeah.
That chain is empty.
Yeah.
So we have no idea what the underlying types expectations
Yeah.
are, right? So and that's fine. The client does not want, the client cannot give access to it or does
Yeah.
not want to give access to it. That's completely fine. But that gets called out as in the QA/bug fixes section,
Yep.
right? So that creates bugs
Yeah.
inadvertently because we cannot validate that.
Yeah.
And that's like a first step. But in general, what you're going to see with a Blitzy output is that there will be some amount of compile time validation
Yep.
that was missed by us.
Yep.
And we're constantly working on closing that gap,
Yep.
but it is not perfect as of today. Let's make that very clear.
Yeah. It's a lot of code.
Yes, it's a lot of code. 230,000 lines of code. It's really hard to perfect that,
Yeah.
but we do our best.
Yeah.
So you might spend like half a day maybe fixing compile time issues.
Yep.
You might spend another few days fixing runtime issues, right?
Yep.
So a week from after you get the build, you're going to be trying to get it to run,
Yeah.
right? But what we've seen is most of the things we've built, ranging from 30,000 lines to 500,000 lines to even 1,000,000 lines, the developers were able to get it compiled and running within the week.
Yeah.
So for all these tests that we do, and even when it's our developers or third parties, we try to ask them to limit all of their effort to this 7-day period, and we've never seen something that wasn't ready to go after 7 days. So that's a good thing for you.
These are mega scale enterprise applications.
Yes, and the context across all of these were like was millions of lines. Right?
Yeah.
So the fact that you're able to get it through to the end means that it is 80% plus. Right?
Yeah.
If it wasn't, you'd be spending a month getting it to run, and at that point you're confused if it even makes sense, right?
Yeah.
So that is definitely not the case. It's workable, and you can get it. You can get done with it in a week.
Yep.
And then beyond that, there's some end-to-end testing that's needed.
Yeah.
Because
in any new application.
Right. In any new application, or even if you modified something,
Yep.
there's end-to-end testing that you should be doing
Yeah.
and validating and making sure. Unit tests, if provided, are a very simple entry point. You can run unit tests and make sure they're working. So when we did this MATLAB to Python refactor, that was a 20-year-old MATLAB, right? And we produced about 150,000 lines of code. We were able to get 248 tests passing in a week, right? And all the GUI running as well. It was native app.
Yeah.
So that was significant, right? So if you have unit tests,
It was a 6-month project that
yes,
was the alternative.
Yes,
Yeah.
the alternative was 6 months, right?
Yeah.
So you got that in a week. If you have unit tests, that's great. Try to get them to run, and that's a good starting point. If you don't have unit tests, use Blitzy to create the unit tests.
Yep.
Right. Do that as the first step. When you connect, let us onboard the code for you. Give you a document. It'll have a testing section, or it'll probably say that there are no unit tests. So you can ask Blitzy to add the unit tests, and it'll crawl through your code, add the corresponding unit tests. You can spend some time, make sure the unit tests are correct and are working.
Yep.
And then your next step could be to add this new feature, and then check that feature using the unit test and or refactor, right? You can use the same process, but you can ground yourself in the unit test.
Yeah.
And we're working on our end so that in the future, we will pre-run and pre-validate those unit tests for you so that you can always have a reliable indicator of how ready the code is, right, out of the box.
You solve for infinite code context first, and then you'll tackle that one next.
Right. Because we trust the developers, right? Blitzy's process is not meant to replace human developers. It's meant to augment them, right?
Yeah.
They already have the co-pilots, and the co-pilots are great complements to us, right? Because take Blitzy's output, use the co-pilot to get it to the finish line, right? Developers already know how to do that. They're great at that. What this solves for is that if you try to push the copilots to their limits, it's a really frustrating process, right? So that is why even in the most advanced studies by, I believe it was Harvard, where they said that even though Copilot increased productivity for junior developers by 50%, it reduced productivity for the senior developers. And that's exactly why senior developers are typically working with more challenging problems on larger code bases. And when you push the limits of those tools, they really struggle. So Blitzy is meant to be this enterprise version of a code generation tool that you can use to batch build products, batch execute refactors, come back the next morning, and use your Copilot to take it to the finish line. And that's the best of both worlds, and that lets you deploy your skills for the correct tasks.
Well, I think that's a wrap. We did enough for today. Let's get back to work.
Awesome.